few months ago, when creating lip portrait videos, I found that using ComfyUI Advanced Lip Portrait allows inputting values to adjust the facial expressions of characters and images. At the time, I thought about building a workflow for automatically syncing expressions to beats. I started researching audio-related plugins and found ComfyUI_Ivan nodes and ComfyUI_Ryan on the inside. The latter was particularly interesting because the author released features to extract audio characteristics, generate masks and weights, and combine them with Animate Diff and IP adapter to create videos. From there, it was just a matter of converting the outputs to advanced lip portrait commands. However, I procrastinated and didn't follow up. Recently, I discovered that the author of the Ryan plugin directly updated it with the functionality I wanted, so I tried it out right away. The results were pretty good. Today, I'll show you how to build a workflow that allows you to upload any portrait and audio file, achieving customizable beat sync videos. This video involves 3 plugins: ComfyUI Advanced Lip Portrait for adjusting facial expressions, ComfyUI_Ryan on the inside for extracting specific audio information, and ComfyUI_Video Helper for loading audio and combining videos. Install these 3 plugins in the ComfyUI Manager. Search for Ryan on the inside. It has a yellow warning icon. Clicking on the small exclamation mark shows that Manager detects a dependency conflict with other plugins. If you've installed and need to use all 3 plugins, you'll have to install them in separate ComfyUI Python environments. The other 2 plugins are fine, with relatively simple dependencies, so you can install them without worry. After installing the plugins, restart ComfyUI. Once everything is ready, let's start building the workflow. First, add the core node expression editor, PHM. Load an image of a character on the left and connect a preview node on the right to observe the results. For easier previewing, I set ComfyUI to autorun whenever there's a change to the workflow. The first option controls the tilt angle of the character's head. I drag the slider with my mouse. Currently, it's set to 7.5. In the preview, the character's head tilts slightly downward. Setting it to the maximum value of 20 makes the tilt more pronounced. Dragging it to -20 raises the head higher. We'll use this option to simulate nodding later, though with a smaller range. About 5 should suffice. Let's test another option. This one is for head shaking. The further the value deviates from 0, the greater the angle. The AAA parameter represents an open mouth expression. I tried it, and the effect works well. As for the other options, I'll show you a demonstration I generated using code. I won't go into detail here, you can choose your favorites when using it. Clear the previous workflow. Now, we'll sync the characters nodding to the rhythm of the music. Add the Load Audio node from the Video Helper plugin. Compared to the default system node, it allows selecting start and duration times, making debugging easier. Upload an audio file. I used a short chord progression from this website, which is perfect for beat sync videos. The first 2 seconds of this audio have no sound, so I set the start time to 2. I leave the end time at 0 to extract the remaining audio. Connect a preview audio node. Click Run to listen. You'll hear it has a nice rhythm. Next, connect an audio separator simple node. This splits the input audio into 4 tracks: drums, vocals, bass, and others. Why no piano or guitar? The current model doesn't recognize them yet. On the left, load the model. The plugin supports 2 models, UMXL and UMXK. The former is newer, but not for commercial use. For this demo, I'll use the default UMXL model. On the right, connect 4 preview audio nodes corresponding to each output. Click Run, and on the first execution, it will automatically download the model from GitHub. Alternatively, You can manually download it and place it in the models/openunmix directory. Once the process is complete, listen to the results. The drum track is distinct. The vocal track is silent. The bass track is low-pitched. And the other track seems to include some piano sounds. For syncing beat videos, I prefer using the drum track. Next, connect an audio feature extractor first node to convert the audio into the feature structure we need. There are 5 different extraction strategies, each suited for different purposes. I'll use amplitude envelope, which excels at capturing dynamic characteristics of signals and pairs well with drum rhythms. The width and height parameters are irrelevant here and can be ignored. Keep the frame_rate at the default value of 30. Later, when merging the video, ensure the FPS matches this setting. By default, the extracted feature values range from 0 to 1. Add a feature renormalize node to convert the values to a range of -1 to 1. Then add a preview image node and click Run. The waveform appears, zoom in to check, and the value range is correct. Switch to another audio track and run it again. Zoom in to see that the waveform changes accordingly. You can select different audio outputs based on the song you're working with. In this case, I'll stick with the drum track. Add a Flex Expression Editor node to convert the features extracted from the audio into parameters for adjusting facial expressions in LibPortrait. Connect a Load Image node on the left, and use the same character image as before. This node has numerous parameters, and some might look familiar. That's because the author directly incorporated code from ComfyUI Advanced LibPortrait, so the expression editing functionality works the same as described earlier. One parameter to note is crop_factor. After detecting the face, the editable image range is determined by multiplying the face bounding box by the crop_factor. Generally, the larger the range of accessories or hairstyles on the head, the higher this value should be. Now, there are only 5 parameters left to configure. These restrict the final values to the expression editor's range. Since the result is calculated using multiplication, it can easily exceed the range. This is essential, so keep it enabled. Strength and feature mode will be explained together shortly. Feature threshold is a value between 0 and 1. For example, if set to 0.5, all feature values with an absolute value below 0.5 will be ignored. Feature param is the expression to edit. For nodding, I'll use the default rotate_pitch. The node supports 2 modes, feature_mode absolute and relative. These are 2 different methods for calculating the final value, with the formulas as follows. Here's a brief summary. If you want the motion amplitude to be directly tied to the feature values, choose absolute mode. For example, the 3 parameters controlling head movement have an adjustment range of -20 to 20, making them better suited for absolute mode. For other motions, where you want movements to fluctuate proportionally around a preset initial value, rather than 0, use relative mode. In my case, I'm working with nodding. The feature value range is -1 to 1, with an initial value of 5 and the default strength of 1. In absolute mode, this results in a nodding range of -5 to 5. Add an Advanced LibPortrait (PHM) node. Connect the motion_link output from the previous node to this one. Then link the command output by dragging it to the command field of the Advanced LibPortrait node. It will auto-connect. This allows the processed values to be passed to the expression plugin for precise editing. Retargeting_eyes, retargeting_mouth, and tracking_src_vid are only needed when inputting a video and can be ignored for now. The crop_factor was already configured earlier during command generation and will be overridden here. Turn_on determines whether this node is active. Keep it set to true. The last option must be enabled. Otherwise, when inputting a single image, the node won't generate a video. Finally, we're near the end. Add a video combine node. Use the original, unseparated audio as the sound input. Set the frame rate to match the previous nodes. I'll adjust it to 30 fps. Select MP4 as the output format and click Run to see the result. As shown in the demo, the character starts nodding to the rhythm of the music. It's so synchronized that it makes me want to nod along. This workflow can also be modified slightly to support editing multiple expressions sequentially. Tidy up the workflow and rearrange the nodes. Duplicate the Flex Expression Editor node and connect its motion_link output to the corresponding input of the previous node. For consistency, I'll still use the drumbeat features for the input. But you can experiment with vocals, bass, or other tracks. It's fun to mix things up. Connect its motion_link and command outputs to the Advanced Live Portrait node, replacing the previous connections. Adjust the parameters by setting the earlier head tilt value to 0. Assign a starting value of 12.5 to blinking, wink, change feature_perm to wink, and set feature_mode to relative. This makes the blinking range 11.5 to 13.5. No need to adjust other parameters. Click Run and check the results. The character now nods and blinks in sync with the drumbeat. That's it for my demonstration. You've got the method, now unleash your creativity. Today's video ends here. I've shared the plugins, models, and workflow in the description. Feel free to explore them. See you next time.